My name is Blake Morris. I'm with the Tutoring Solution, and today we are going to talk about polynomials. Now, polynomial comes from two roots. It comes from poly, and it comes from nomial. Now, poly means many, and nomial means terms. Now, when we talk about polynomials, they're simple because they only contain three different types of items. The first one that polynomial contains are constants. Now, constants are, as they seem, constant. They're never going to change. So you can pick any number, and that's a constant. You know, you have 5, you have 10, you have, 1 million, any number, and it's a constant. And as it says, it's never going to change. The other thing it can contain are variables. Now, variables can change. So you could have, the two most common ones are obviously x and y. But you could pick anything, A, B, C, any letter of the alphabet, and it works. And that'll be a variable. And now sometimes these two get combined, and you end up with 5x. Now, 5x is a constant, as you can see here, but it also has a variable part. So when you look at this whole piece right here is a variable because you can change it. Now, the final part that cannot change is exponents. Now, exponents are very picky when it comes to polynomials. Exponents have to be greater than 0, or greater than 0 to an extent. So they can't be negative at all. They cannot be -1, it cannot be -2, just doesn't work. These are no good. Do not do that when you use exponents. If you use a negative exponent, it will not fall under the category of a polynomial anymore. You can use anything above negative values, but nothing in the negative realm. So you can use, let's see, x squared, y to the 4th, a to the 1000th, any of them. It does not matter. They all work. But the one thing you have to keep in mind is absolutely no negative exponents. If you use a negative exponent, your problem is not a polynomial anymore and will not work. Moving on from there, we're going to ask ourselves the question, is it a polynomial or is it not? Okay, now, is it a polynomial is pretty simple. As we just talked about, you have your constants, so you have, 3x and x squared, okay? So, any of these are polynomials. Now, what are not polynomials, you ask? So, anything with a negative exponent, like I did say, and we're going to put these in red so that it's very clear. Alright, so 3x to the -2. This is no good. Don't use that. Okay? Let's see. What else? Anything with an exponent in the denominator, or with a variable in the denominator. So if there's ever a variable in the denominator, this is not a polynomial. Aside from these two exceptions, everything else is polynomial. Alright, so if you're dealing with a problem and it says, oh, this is a polynomial, but it has a negative exponent or a variable in the denominator, then you guys know that that is definitely not a polynomial. So now that we know what's a polynomial and what's not a polynomial, let's move on to something a little bit, not more complicated, so to speak, but it's important, okay? And a lot of people don't like to do this, but I feel like you guys should do it. Let's say that you have some huge polynomial. You got x squared plus x cubed plus 5x to the 6th plus 7x to the 4th plus x. Alright, so you got this huge polynomial, okay? Now, we're not dealing with addition and subtraction and multiplication of polynomials yet, but we will. And when you do that, you want to be in, as I wrote at the top here, you want to be in standard form, okay? So, what is standard form? Standard form basically takes all of these exponents, 4, 6, 3, 2, well, you have imaginary 1 over here, and they take all of these, okay, and they put them in order from greatest to smallest. So, we take 5x to the 6th plus 7x to the 4th plus x cubed plus x squared plus x. And as you can see, this one is the largest, and it goes right here. And this one is second largest, and it goes right here. And so on and so forth. This one here, and this one here, and this one here. Okay, so now that it is in standard form, this is standard form right here, and this is good. Do this. So now that we have everything in standard form, let's try adding polynomials. Now, adding polynomials is not too tricky. Okay, so there's two different ways we can do it. Alright, so take this polynomial that you have right here. This one right here, okay? And I'm going to make up another one. Alright, so now we have x to the 6th plus 4x cubed plus x plus 7. Okay, so we are adding these two polynomials, okay? So we're adding this one on top and this one on bottom. When you add polynomials, you always have to add the like terms. Okay, so if we look at the first polynomial and we look at the second polynomial, we see that we have two terms that have x to the 6th. So these we can add. Okay, so if we add those two, it's very simple. 6x to the 6th, okay? Because basically that's a 1x to the 6th plus 5x to the 6th, you get 6x to the 6th. Now, we look at 7x to the 4th in the first polynomial, and we don't see any matching term in the second polynomial. So, therefore, very simply, it remains the same, okay? Then we look at x cubed. Oh, look at that. Look at that. We have two x cubed terms, okay? So, those are going to add to 5x cubed, because as we know, anything without a number before it is 1. So that's 1x cubed plus 4x cubed gives you 5x cubed. We look at the x squared, and there is no matching variable in the second polynomial, so the x squared remains the same. There we go. And then we look at the x, and oh, voila, there are two x's, one in the first polynomial and one in the second polynomial. We add those together, and we get 2x. And then we look at the last, but not least variable, the 7 right here, and there is no other constant in the first polynomial, so the 7 remains the same. So, this is your final answer after adding those two polynomials. Now, let's do one more, just for good practice. So in the last example, we did it by merely matching like terms. Okay, now in this example, we're going to do it a little bit different. We're going to add these by a way called addition of polynomials by columns. Okay, so I drew this big line, and over on the right side, I'm going to put a plus sign. Okay, so we're going to write out our first polynomial, 5x squared plus 4x minus 3. And on the bottom, we're going to write out our other polynomial. But this time, we're going to match up our like terms underneath where they match up. So 6x cubed does not have a spot, so that's going to go at the very end here. There is a x squared though, so the 3x squared is going to go there. And do not forget the sign. The sign is very important, okay? Do not forget to move them. Now, moving on from there, we will put 2x, or negative 2x, excuse me, and do not, once again, forget the negative. Always remember signs. Signs, 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 signs. Signs are very important. Okay, now we've put our second polynomial in our first polynomial. And I'm going to kind of divide this. I don't want to mix them. So we're going to add at the far right first. So there's nothing in this area, so it becomes -3. In this area, it becomes 2x, because 4x plus a -2x gives you 2x. 5x squared, a positive 5x squared, plus a -3x squared gives you a 2x squared. And the 6x cubed remains the complete same. And our final answer is this little guy right there. There we go. Now we know how to add polynomials, and it's pretty straightforward. I'm pretty sure you guys totally know how to do it now. Going on from there, we're going to subtract polynomials, and subtracting polynomials in concept is the same exact. The only thing that's going to change is in regards to this little guy right here, the minus sign. Okay, he's very important, and I'll show you why. So, for me, adding by columns is honestly the easiest way. So, I'm going to draw another line, and I'm going to set everything up. So I got 5xy squared minus 4x plus 3y minus 2. So, here's where the negative sign becomes very important. The negative sign always changes the signs within the parentheses to the reverse. Okay, so for instance, this sign, right, with this 4 is a positive. Okay, but now that there's a negative there, it's going to change to negative. So it's going to become -4xy squared. And this sign is a positive. So that sign is going to become -2y. And always remember, match up the terms. So match up these, and match up these, and there's no other terms, so it works out perfectly. Alright, so very simply, we're going to add everything down then. Put a plus sign over there. So 5xy squared plus a -4xy squared gives you 1xy squared. 5 minus 4. Come on, guys, you got this. -4x, there's nothing to add to it. Plus 3y plus a -2y is going to give you plus y. And -2 is your other value. And there is your answer. You guys totally got it. Now we're going to move on to a little bit of a more complicated problem with all kinds of different polynomials, addition and subtraction. So look at this polynomial. And before you start freaking out, you guys got this. First thing we're going to do, as we've done in the past, is we're going to draw our line. We're going to do this by columns again, because it's the easiest way, and it lays everything out so perfectly. Once again, write your first polynomial. Just write it out. Just write it out. Now, we look, and we go, oh, sweet, we got a plus sign. Easy. No sign change. Okay, so -3x squared goes under the 4x squared. -2x goes under the 3x. And remember again, sign, 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 sign. Always remember signs. You guys forget signs? It's all on you. Just kidding. And finally, we're going to move to this last polynomial. Okay, now here's where it gets tricky. There is a negative. So, don't worry, don't panic. Negative means reverse signs. Okay, so negative means that this sign right here becomes positive. Pretty easy. And that goes under the x's, obviously, because it's still x's. And the positive 5 becomes a -5. And there we go. Alright, so let's do it. So -2 plus a -5 is -7. And now a 3x plus a -2x plus a 7x is equal to an 8x. And 4x squared plus a -3x squared is x squared. And there you guys go. For the middle x column, if you had a little bit of trouble, I'll slow it down a little bit. 3x plus 7x is 10x, and that's positive. And a 10x plus a -2x is equal to an 8x. And there you guys go. You guys got this totally. That's your answer. So there you go. There's polynomials, addition, and subtraction. Going on from addition and subtraction of polynomials, we're going to move on to something a little bit more advanced, a little bit more complicated, but overall, you guys can totally knock this out. You guys got this. First, we're going to learn how to multiply polynomials, and then we're going to do a little bit of division of polynomials. Now, multiplying polynomials is pretty straightforward and pretty simple. What's 10 times 3? And that's going to give you 30. And x squared times x cubed is going to give you x to the 5th. Now, let me break that down for you. These two, you have x squared times x cubed. And whenever you multiply a constant base, you simply add the exponents. So you get x2 plus 3. And this is equal to that. There we go. Let's move on to a little bit of a trickier multiplying polynomials. That one's pretty easy. So you have 2x, and you're going to multiply that times 3x squared negative 2x. And so you're going to multiply this initial term times that bigger term. Okay, so whenever you multiply a single variable, this guy, times multiple variables, you have to multiply everything within, so this guy and this guy, by this. Okay, so you're going to first multiply 2x times 3x squared, and that's going to give you 6x cubed. And then you're going to multiply 2x times a negative 2x, which is going to give you negative 4x squared. And remember, just what I said, right up here. Okay, so x to the 1, x to the 2, 1 plus 2 is equal to 3. And x to the 1 and x to the 1 is equal to x to the 2. And this is your answer. Alright. Now, let's even move on to something a little bit more complicated. So you have x plus 2, and you have x plus 4. Okay, so now this guy's a little bit challenging. Okay, so remember what I said? You have to multiply each of the terms here. So you have to multiply this one times this guy, and you have to multiply this one times this guy. Okay? So let's rewrite that. Alright, so we're going to have x times x plus 4, and then we're going to have plus 2 times x plus 4. Okay, and now if we look at this problem right here, and we look at this problem, they're the same. They're exactly the same. You just have two of them now. You have x times x plus 4, and you have 2 times x plus 4. So very simple. You go x times x, which is x squared. You go x times 4, which is 4x. And then you go 2x plus, no, it was very, very bad x, plus 8. And there we go. And so now you would simplify, which we're going to bring it up here for now, and you're going to have x squared plus 6x plus 8. And that is your answer. Let's do one more problem before we move on to division. Alright, so we have these two polynomials right here, and you're multiplying them. So we're going to break them up again, and you have 2x times 3x plus 1, and then you have that is added to 3 times 3x plus 1. Alright, so we're going to do the first one, and 2 times 3 is 6. X squared, remember, because x to the 1 times x to the 1 is x squared, plus, and then 2x times 1 is 2x. Then over here, you have 9x, and you have plus a 3. Now, we're going to go back to the lesson I originally taught you, addition of polynomials, and 6x squared doesn't have anything to add to, so 6x squared remains the same. And then 2x and 9x become 11x. You guys got that? 2 plus 9, 11. And 3 remains the same. And voila, there's your answer. And basically, all polynomial multiplication will rely on this similar rule. You'll see certain problems where it's like x plus 3 plus x squared times x plus 1. And this is literally the same thing. You're going to take x, and you're going to take 1, and you're going to multiply it times this whole thing, you're going to multiply it times this whole thing, and you'll simplify, and you're going to get some value down here. And other than that, though, that's all multiplication of polynomials is. So for the final piece of today's lesson, we're going to talk about dividing polynomials. Now, dividing polynomials is pretty simple. Up on the top left corner here, I have a simple example. When you divide polynomials, you have to first break it into two pieces. So in this one, you can see that there's two distinct regions. There's this one, and then there's this one. Okay. 3x squared over 3x plus 9x over 3x. And if you look at these, they both have the same denominator, and you just basically split up the top, the numerator part. Okay, so now that you've done that, simply you're gonna cross out. So the 3 and 3 go away, and the x and the 2 go away, making it 1. Okay, so over here you have x to the 1 now, or simply x, and on the right side, the 9 and the 3 cancel, giving you 3, and the x go away entirely. So you get 3 there, you get 3 there, and your final answer is x plus 3. Let's do one more example. This one, a little bit more complicated, but overall, not too bad. You guys got this. So, if we look at the denominator and the numerator, they have something in common. Now, sometimes it's going to be really tricky to find. Sometimes it's going to be a little bit easier, like in this example. Alright, so let's break it up like we did in the last part. So we have x squared and x minus 1, and that's going to be over x minus 1. And then we have plus 3x minus 1 over x minus 1, and then we have minus 2x minus 1 over x minus 1. Real simple. We look at it and we see it instantly. It's staring us right in the face. We see that all of them have this guy right here. They all have x minus 1 over x minus 1, and guess what? That is the same exact thing. So those all go bye-bye. And now you're left with x squared plus 3 minus 2, which is also equal to x squared plus 1. And that's your answer. So, brief recap on what we went over today. So, first we talked about polynomials and what the word in general means. We talked about what's in a polynomial, whether it's a constant, variable, or an exponent. And only those things, remember that, only those things make a polynomial. We also talked about is it or is it not a polynomial. And the two exceptions are it cannot have negative exponents, and it cannot have a variable, such as x or y, in the denominator. Remember that. Third, we talked about standard form, which is basically just getting the exponents in order from greatest to smallest. And then we talked about addition and subtraction of polynomials, which you guys got down for sure. It's easy. And then we talked about multiplication and division of polynomials. I've been Blake Morris, and I hope you guys learned a whole bunch today.